Alright, so in our study of conic sections, I'm now going to move to a hyperbola. Okay, so if you look at the entire diagram that you're looking at right now, this whole thing is called a hyperbola. Forget about the triangle that is inside. This is just there as an aid to help you understand what I'll explain. Okay, but instead think of a hyperbola to be something that looks like this. Okay, kind of like a set of two parabolas. Okay, that are facing in opposite directions. This is what a hyperbola is. Now, what defines a hyperbola is the fact that if you try to measure any point on the hyperbola, let's say we take that point, an arbitrary point, let's call it P, which is x comma y, and then we come up with two fixed points, let's call them f1 and f2 from each parabola, and then these are two fixed points. So the definition of what a hyperbola is the difference from P to F1 and again from P to F2. So let's call them distance 1 and then distance 2. Okay, so the absolute value of the difference between D1 and D2, okay, is a constant. Okay, that's basically the basic definition of what a hyperbola is. So if I'm to get another point on the hyperbola and then again measure its distance from f1 and then again to f2, again its difference, okay, if you're going to call it d3, d4, again the difference between the two distances is going to be a constant. Okay, that's basically what a hyperbola is. Now, a few things that will make it more interesting is we have to understand a few things here. Okay, so let me try to redraw it again, and then we try to come up with a few names. Okay, that's not too perfect. Let me just use this. Okay, well, it looks too complicated. I'll just have to draw something for myself again, like that. Okay, so first of all, to start with, there is what we call a transverse axis. So a transverse axis is a line that cuts the two fixed points we called f1 and f2. That's what a transverse axis is. So it cuts the 2 points. Okay, so that's what the transverse axis is. So the other thing you can actually notice is that it actually also cuts the vertices. It cuts the hyperbola at its two vertices, right? Okay, you know what a vertex is from a parabola, right? These bottom parts. So a transverse axis passes through a foci. By foci I mean the two fixed points. So when it joins the 2 points, it also cuts the hyperbola at two of its vertices. That's one thing that you can note. Now the midpoint of the transverse axis, which can also be called the focal axis, its midpoint is known as the center of the hyperbola. Okay, that's very important as well. Now, of course, the hyperbola has got asymptotes which cut it through the center. It has got two asymptotes that may be like that. These ones are very key when it comes to drawing a hyperbola because you can just draw them and then just know that these can never cut or meet with the hyperbola at any particular point. Okay, so I'm here to give you the full written definition, but I was just trying to give you the basics of what you need to know. Okay, so from that we can now come up with a full definition written down. I'll give you two, whichever you find simple. So this is just describing what I've already explained. So the set of all points, okay, so a set of all points for which the absolute value, okay, for which absolute value of the distances or the difference between the distances from the two fixed points, f1 and f2, which can be called the foci, is a constant. So a set of all points for which the absolute value of the difference between the distances from the two fixed points f1 and f2, which are collectively called the foci, is a constant. That's one way you can actually define it. Very simple, right? I'm just describing what we're trying to say. The other way would be, you can just say the locus of all points. Okay, you can think of the locus as a set, so such that all, or how can I put, okay, such that the difference, so the locus of all points such that the difference, okay, of its distances, so a difference of its distances from what? So from the fixed points f1 and f2, collectively called the foci, is a constant. So that would be a basic definition of what a hyperbola is. Okay, now using this diagram here, this is just a summary of what I've talked about. So far, I've said there are two asymptotes that actually meet at the center. The center is the midpoint of the transverse axis, which cuts the foci f1 and f2. Okay, so the transverse axis also cuts the vertices. I did mention that. And then I said this is actually a demonstration of, again, what a hyperbola is. Measuring of distance from f1 to p, and then again from f2 to p. So call that d1, call this d2. The absolute value of their difference is what gives you a constant. So it doesn't matter what point you pick, and that's what the set of such points is what actually define a hyperbola. It can be the same, you can measure it from the other side as well. Doesn't really matter. Okay, so let's move on now and talk about and drive the equation of a hyperbola that will help us be able to determine the vertices and be able to determine the foci, that's f1 and f2 when asked, and also be able to determine the equation of asymptotes when you're also asked. Okay, so let's just do that.